Greetings, and welcome to my introduction to digital business transformation. I'm Ted Simpson, Cengage author and adjunct computer science instructor for UW colleges. Well, according to Enterprise Project, digital transformation is integration of digital technologies into all areas of the business, thereby fundamentally changing how you operate and deliver value to the customer. And cloud computing is a major part of implementing this new digital transformation. Well, digital business transformation is not new. Let's face it, in past generations, digital business transformation may have included things like the punch card back in the 50s, mainframe terminals, and mini computers in the 60s and 70s. And then in the 80s, 90s, we got into distributed processing using desktop-based microcomputers, file and print servers, the Novell era, if you will. But more recently, digital business transformation has involved technologies like virtualization, hyperconvergence, virtual desktop infrastructures, and now public cloud services. Let's take a look at how these work together. First of all, what technologies are actually driving digital business transformation today? Well, virtualization has been around for some years, but it's the foundation upon which we build a software-defined data center. Hyperconvergence is going to bring in other aspects to create this software-defined data center. And then cloud computing allows us to extend the software-defined data center, providing more agility and capabilities without increasing the cost of the equipment. Then we have digital and device mobility, and new applications like artificial intelligence, big data, and analytics. And then, last but certainly not least, security. Without security, none of these new technologies are going to be implemented. So security has become paramount, and cyber security can actually be enhanced through the use of cloud computing. Let's take a look at some of these technologies individually. First of all, hyperconvergence. Hyperconvergence is basically an infrastructure model in which hardware devices are represented as software structures, therefore making them independent of the specific hardware device. Virtualization of computer resources, such as the CPU and memory and hard drives and so forth, into virtual machines is, of course, one of the first levels of hyperconvergence. Software-defined networking, storage area networks such as SANs, and public clouds and public cloud storage, all part of hyperconverging, making pools of resources that we can assign flexibly. And as I mentioned, virtualization is actually a hyperconvergence process. It uses a software layer called a hypervisor to create virtual or software structures containing hardware resources such as CPU, memory, storage devices, and networks. And these resources come together in what's called a virtual machine, as you can see in the diagram here from our textbook. This virtualization process actually dates back to the 1970s when IBM did research in setting up the basic foundation of virtualization process. Later, VMware implemented a lot of this technology in the x86 platform. Well, what do we mean by cloud computing? Well, cloud computing, according to the National Institute of Standards and Technology, defines cloud environments as 6 characteristics: on-demand self-service, the ability to allow a customer to quickly provision virtual machines with hardware and software resources they need without waiting for outside assistance. They can do this automatically. Broad network access means we have access to services over the network using a web browser or standard interface from any location and from a variety of devices. And resource pooling is where we use hyperconvergence to take resources and put them into pools so they can be allocated in an on-demand fashion. Elasticity allows the resources to be quickly scaled in and out by the consumer. The consumer pays only for what resources they use during a certain time period. And reliability and redundancy, of course, become primary considerations, as well as load balancing and disaster recovery. So implementing a service with these 6 characteristics is what's going to make a cloud computing service. And there are a few models that we can use. Companies can implement their own private cloud containing these 6 services just for the use of their own staff, or a community cloud might allow a few organizations to work together and create a private cloud for the members of that community. A public cloud service, on the other hand, is offered through some type of cloud service provider, or CSP, examples of which would be Microsoft Azure, AWS, IBM Cloud, and Google. And they offer this service basically so they can make dollars off their servicing the customer. A hybrid cloud is where we bring together our on-premise data center with the public cloud services in order to extend the data center and provide us with additional capabilities without having the cost of actually building that infrastructure in-house. Now, according to IDG, 32% of IT spending will be in this area in 2020. Another 20% of the budgeting will be in the private community cloud environments. The reasons that we're seeing a lot of businesses flocking towards the public cloud are things like agility, scalability, cost, implementing disaster recovery. We also have the implementation of new technologies like artificial intelligence, big data, or deep analytics. Public cloud allows us to extend our data center. This is called infrastructure up, or in some cases actually replace certain aspects of our data center, which is called a cloud down approach. The public cloud has brought us a new type of worker that's becoming more and more important in the IT workplace. This worker is called the cloud, or gig worker. Well, what is a gig worker? First of all, they're independent, working usually from their own home or office. And they work each day in a fully cloud-enabled environment, having access to many of the enhanced cloud-based tools, including things like artificial intelligence and big data. They also provide highly specialized skills that are often used in specific project work, most of this work being done with a web browser. Today, more and more businesses are using cloud-based gig workers, and so the IT needs to provide a cloud-based secure infrastructure that these gig workers can be used in order to provide our business with a competitive edge. So teaching digital business transformation concepts and technologies is an important part of preparing students for job placement in today's data center. As you can see from this diagram, there's quite an overlap between virtualization and cloud skills, including things like infrastructure as a service, hybrid, and private clouds. Because of this, teaching virtualization, along with hyperconvergence of data center resources, is needed for digital business transformation and cloud certifications. Our hands-on virtual computing book and MindTap course provides this path. For more information, please view my video on teaching digital business transformation skills using our hands-on virtual computing and MindTap materials in your curriculum. So thanks for listening to this presentation, and have a great semester.